Hello students and welcome to Chemistry B. I'm Ms. Slate and today we're going to talk about the molar volume of a gas and how we can use that to make mole conversions for stoichiometry. But first, let's look at a simulation so that we can examine what factors actually affect the volume of a gas. So here in this simulation, I've got a box and we've got a thermometer that shows temperature, a gauge that shows pressure, and the size of the box is related to the volume of the gas. So I'm going to put a few gas particles in the box. And the first thing that we're going to see is how volume is affected by temperature. So if I heat the gas, we can see that the gas will actually expand, right? And it'll take up more space. But if we cool a gas, it'll contract and it'll take up a lot less space. Pressure also plays a role in the volume of a gas. If pressure is low, you're going to have a large volume of a gas. However, if you apply lots of pressure, you end up with a small volume of a gas. So both temperature and pressure will change the volume of a gas. So let's write down those factors. You can take your notes in your notebook like normal, or you can follow along on page 7 of your stoichiometry packet. So first off, like we said, the two factors that affect the volume of a gas are temperature and pressure. What this means is if we want to compare the volumes of two gases, we have to keep these two factors constant. We have to keep temperature and pressure constant. And so the main way that we do that is by defining a standard temperature and pressure. Standard temperature and pressure is usually abbreviated as just STP, where the standard temperature of a gas is considered to be 0 degrees Celsius, or 273 Kelvin, and standard pressure is 1 atmosphere, which is equivalent to 101 kilopascals, or in imperial units, about 14.7 psi. We will typically be working with pressure in atmospheres because that is the unit used by the International System of Measurement. But you will also might see kilopascals since they're kind of the most common metric unit for pressure. Now let's define the molar volume of a gas at STP. So if you have any gas at standard temperature and pressure, 1 mole of that gas will have a volume of 22.4 cubic decimeters. So this means anytime we're doing mole conversions, if we're converting to volume, we're converting to volume in cubic decimeters. So if a question asks you for volume in a different unit other than cubic decimeters, you'll have to do a further metric conversion. But most of the time, if it just says convert to volume, you can just use cubic decimeters. Now let's look at an example. Our example says convert 44.8 cubic decimeters of nitrogen to mass in grams. So again, notice we're starting with a volume and they want us to end in mass. So this is going to be a multi-step problem, and it's useful to look at the mole diagram to help us. So I'm starting at volume and I want mass. That means I'm going to have to convert from volume to moles and then from moles to mass. So first thing we're going to do is convert from volume to moles. So I'm going to start with what I was given, my 44.8 cubic decimeters of nitrogen gas. Again, it's important to get into the habit of labeling what substance you're doing the conversion for, because that's going to become very important a little bit later on in the stoichiometry unit. Next, according to the mole diagram, we needed to convert from volume to moles first. Well, I have cubic decimeters, my volume, so to cancel that, it needs to go on the bottom, and I want moles, so it goes on the top. Again, we just said the molar volume of a gas is 1 mole is equal to 22.4 cubic decimeters at standard temperature and pressure. We're going to be assuming that pretty much all of our gases are at STP because we wouldn't be able to do these conversions if they weren't. At this point, my units of cubic decimeters cancel and I'm left with moles. The next step in our mole diagram was to convert from moles to mass. So at this point, I have moles, so it needs to go on the bottom to cancel, and I put grams on the top. Now, at this point, we need to remember that nitrogen gas is a diatomic molecule. So we have to determine the molar mass of nitrogen before we can actually finish this calculation. So we got to look at the periodic table, find the mass of nitrogen, and multiply by 2. So the mass of nitrogen is 14.007, and we're going to multiply that by 2 to find the molar mass of the nitrogen molecule. And that gives us a molar mass of 28.014 grams per mole. And now I can use that as my conversion factor between moles of nitrogen gas and grams. 1 mole of nitrogen gas has a mass of 28.014 grams. Units of moles cancel, and I'm left with just units of mass. So now I'm going to do the conversion math. So I'm going to take 44.8, divide it by 22.4, then I'm going to multiply by 28.014. And rounding to significant figures, we get an answer of 56.0 grams of nitrogen gas. And that's how we can use the molar volume of a gas at standard temperature and pressure to convert between moles and volume.